Okay, today's topic is graphing quadratic inequalities. So when we deal with quadratic inequalities, inequalities are the symbols greater than, less than, greater than or equal to, less than or equal to. So those are what we're going to be looking at in this section. Now to graph these, we want to make sure we understand what we're looking at. So the answers to inequalities is a region of the graph in which the solution is true. Okay, so we want to know which area is true. Now we have a region here because when I say x is greater than 5, it could be any number greater than 5, and that's an infinite number. You've got 5 or 6, 7, 8, but you also have numbers like 5.5, 5.6. So it's an infinite number. So what we're going to do is we're going to represent this with shading. And when you shade on the graph, that shows your solution. Now there's 3 steps that you're going to go through when you're solving these inequalities. First is you're going to graph them. So you're going to graph them just like you would if it was a normal equation with an equal sign. The inequality is not going to play any role there. Okay? Then you have to decide on one of 2 things. Is it solid or is it dashed? And that is your barrier line. So the solid line occurs when you have the less than or equal to or the greater than or equal to. The dashed line occurs when you have just the less than or the greater than. So the difference there is the equal to. Now the second thing you're going to do is you're going to test a point that's not on that parabola. You pick any point not on that barrier line and you substitute it into the equation. And then the third step is you're going to shade that graph. And we'll see these 3 steps in action as we go forward, but those are the 3 that we want to use. Okay, so keep those in mind. Alright, so we've got a couple here that we're going to look at. Now, graphing the equations we saw last section, and you're going to do this the exact same way. So if you guys remember, we need 2 things. We need a vertex and we need a y-intercept. Now the y-intercept is always the easy one. It's 0, c. So in this case it's 0, 1. Now for the vertex, you've got a couple different ways. You can put this in vertex form. You can do the negative b over 2a and then substitute that back in. It's completely up to you. So find a way that works for you. For this purpose, I think negative b over 2a is a relative easy purpose. So here's b, which is 2. There's a, which is 1. So negative b is negative 2 over 2 times a. 2 times 1 is 2, which gives you an x value of negative 1. And so your vertex has negative 1 right there. Now if you guys remember, what you do next is you take that negative 1 and substitute it in. So we take negative 1 and substitute it throughout this original equation. So you have negative 1 squared plus 2 times negative 1 plus 1. And you solve that. So negative 1 squared is 1. 2 times negative 1 is a negative 2 plus 1. So that gives you the point, or the value of 0. And so that's the point negative 1 and 0. So once you have those 2 things, you come over your graph and you graph them. So negative 1, 0 is the point right there. 0, 1 is the point right there. And then using the line of reflection, we also have a point right here. So I've got my 3 lines. Remember, since a is positive, it has to open up, which matches this graph. Okay, now we go back and we look at our inequality. Okay, the inequality in this problem is a greater than symbol. So greater than means it's going to be a dashed line. So I take my graph and I complete that with a dashed line, just like that. Okay, so there's my outline. Next step is we're going to take a point that's not on the graph. And one point that is always a good choice is the point 0, 0, as long as it's not on the graph. And 0, 0 is not. So I substitute it into my original equation. Remember that f of x is the same as y. So I've got 0 for y is greater than 0 squared plus 2 times 0 plus 1. Now solving this out, you got 0 is greater than 1. Well, 0 is not greater than 1. Okay, that's false. So what you're going to do, 0, 0 was right here on the origin. I'm going to put a blue dot there. Since that's false, I have to shade the region opposite of that. So what you have here is basically an outside and an inside of this parabola. The false point was on the outside, which means the true values would be on the inside, and that's where your shading goes. And there's your graph. That's what it would look like. Okay, so grade your graph your barrier, choose if it's solid or dashed, and then pick a point and shade accordingly. Now another way to do this is, look at this symbol. This is greater than. Greater than, if you look from your vertex, greater than is up, and I shaded up, and that's another idea, or another way to look at that. Okay, take just a second, pause the video, and try problem B. Come back in 1 second. Okay, so hopefully you guys paused that video. You had time to work through this. So here's what we've got. The vertex in this case is the y-intercept is 0, c. So you got 0, 4. The vertex, we're going to do x is equal to negative b, so negative 2 over 2 times 1, which is 2, gives you negative 1 there. We're going to take that negative 1 and substitute it in. So negative 1 squared plus 2 times negative 1 plus 4. Now solving that out, negative 1 squared is 1. 2 times negative 1 is negative 2 plus 4. So 1 minus 2 is negative 1 plus 4 is 3, and there's your vertex. So the vertex is negative 1, 3, which is here. Our y-intercept is 0, 4. The reflection point is there. Now I've got my 3 points. I look back at this symbol. That's equal to. So since it's equal to, I've got a solid line. Now to finish this up, I have to choose a point. And notice again, 0, 0 is not on my graph, so I can substitute that in. So we've got 0 is less than 0 squared plus 2 times 0 plus 4, which gives me 0 is less than or equal to 4. And that is true. So since that's true, there's my 0, 0. I have to shade where 0, 0 is. And it's on the outside of my graph. So I'm going to shade everywhere on the outside of the graph. And there you go. You are finished. Alright, so that's the graphing of the inequalities. Now, what we want to also be able to do is to solve these quadratic inequalities. Okay, so here's what we're going to do when we solve these. Solving them turns into a lot like the solving with factoring, okay, or solving using the quadratic formula. And either of these methods still work. For a minute, we're going to forget about the inequality. Okay? So what I want you guys to do is to solve this like you would if there were an equal sign. And we look at it a couple different ways. We can factor. Okay, so I want to try factoring first. Now if you can't factor, you got the quadratic formula. You've got completing the square. You could still even graph it. Okay, so there's a bunch of different methods. For this one, we're going to try factoring first. So I've got x and x that goes there. Two things that multiply to a negative 8 and have a difference or add up to a negative 2. It's going to give you a negative 4, or sorry, take that back, a positive 4 and a negative 2. Now from there, if you guys remember the zero product property, you set each of those equal to 0, solve that out, that gives you a negative 4 and a positive 2 for your solutions. Now what this is essentially, it's the points on your graph. Okay, so I've got negative 4 and I've got 2. It's the points on my graph where the parabola would cross. So if I were to continue my parabola, my graph would cross something like that. Now I don't really know what happens down below, and in these problems you don't really care. What you want to know is it shaded on the left of the negative 4, in between the two lines, or on the right of the 2? And what you're going to do is you're going to choose a point. Now again, a good point to choose is 0, as long as it's not one of my graph points. So I take 0 and I substitute it in. So I've got 0 squared plus 2 times 0 minus 8 is less than 0. And solving that, I get negative 8 is less than 0, which is true. Now, just like before, we shade where our true solution is. Our 0 is in between, so our shading will be in between. Now, what this ends up looking like is part of a line graph. Okay, if I were to complete this parabola, I would have shaded inside the parabola because it's between those two lines. Now to finish this up, you've got to show and represent your answer. Now your answer is how you would represent this shading. Well, if you think of the middle as being the unknown value, that's x. What you could say is the number has to be greater than 4. Or sorry, negative 4. So you're going to say x is greater than negative 4. But the number also has to be less than 2. So you'd say and x has to be less than x has to be less than 2, and so there is your solution. Now anytime you have an and problem, there's one other way you can write this. You can combine these together and put negative 4 is less than x is less than 2, and there's your solution. And we use the less than symbol because of our original problem. does have the less than symbol. Alright, so that's that one. I want to go through one more of these together, and then we'll try one, or have you guys try one on your own. Okay, so for this one, we've got something here that we may or may not be able to factor. We'll have to see. So I put a negative x and a negative x. Okay, remember, anytime it's not a positive 1 there, you have to put this term here. Now we take this negative and multiply across. That gives you a negative 10. So two things that multiply to negative 10, add up to 3, are going to be positive 5 and negative 2. Okay, so we take each of these, set them equal to 0. So x plus 5 equals 0. That's going to give me a positive 5. And then on this one, you've got negative x minus 2 equals 0. Add the 2, divided by negative 1, you get negative 2. So there are my 2 points. So I've got 5 here. I've got negative 2 here. Then the next step, just like before, we substitute in a value, which we'll choose 0. So I've got 0 plus 10 is less than or equal to 0. And the way that I'm getting these first two zeros here and here is I just substitute them in. I know since I have an x in those places, they're going to cancel out. So my answer is 10 is less than or equal to 0, which is false. So the false area is in the middle. Well, we know that the middle's false, and if you guys remember, these two lines, here and here, represent a parabola. So if my parabola were to come around, the inside is not shaded, that means the outside is shaded. And it wraps all the way around the bottom and would shade that side as well. So based on this, if I have my two x values here and here, okay, this first one says that x has to be less than negative 2, but because my original answer has an equal to, this one does as well. The second one is greater than 5, and again, since my original had a equal to, that one does as well. And so these two shaded opposites is an OR problem, and there's your solution. Alright, I want you guys to take a minute or so, try and solve that one out. Just pause the video and come back when you're ready. Okay, so to solve this one out, we're going to put a negative 4 in each of these. Okay, we'll throw your x on there as well. Multiply across, you got a negative 28. So two things that multiply to negative 28 have a difference of 5. Well, without listing these out, it may not know for some of you guys. So you got 1 and 28, 2 and 14, 4 and 7, and that's kind of it. So what does that tell you? Well, what that means then is, since none of those work, we've got to go to the quadratic formula. Okay, so this factoring is not an option here, which is okay. Okay, so we go through the quadratic formula. You got negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, so continue to solve this down. You got negative 5 plus or minus the square root of 25. Now a negative times negative is 16. Okay, a positive 16, so you got 16 times 7. And you can go through this, so that's 42. You got your 2, got your 4 up there, and that gives you 112. So you got plus 112. On the denominator, you have negative 8. So you've got negative 5 plus or minus the square root of 137 over negative 8. Alright, so looking at that, it's not the easiest number, but it is just a number. Okay, so what we're going to do is we're going to grab a calculator and figure out what those numbers are. So the first one, negative 5 plus the square root of 137, and then divide that by 8. Your first number is 0.838. Now the second one, you go through the exact same process, except for instead of a negative 5 plus, it's a negative 5 minus the square root of 137. Divide that by a negative 8, and you get 2.088. Okay, so those go on our number line. Okay, so here's 0.838. Here's 2.088. and we substitute a number in. So if we choose 0, now 0 is over here on the far left. So I substitute 0 in, I get 0, 0, 7 is greater than 0. And that's true. So when it's true, I shade in the direction of the true spot. And the true is on the outside. And from there, to finish this up, you lay this out as to how this works. So this is going to be x. Our symbol is just a less than or greater than, so I don't need my equal to. So x is less than 0.838, or x is greater than 2.088, and there's your solution. And remember, sometimes these just work out that way. Okay, you're not always going to have a perfect number that works out. However, these are just parts of the graph, and that's okay. All right, give these a try. If you need some help, let me know. Otherwise, we'll talk to you soon. All right, good luck.